Group 19 welcomes you to Iowa State University's IMSE 2019 Capstone Project with Windsor Windows. Our objective for the first project was to reduce the time spent searching for glass. We analyzed the project through a work sampling analysis, a time study, and a process flow map. The scope of this project was to evaluate the delivery and storage of glass on the production line. Previously, the operators at this workstation spent a great amount of time searching for glass. An operator would search through multiple 50-piece glass racks for the corresponding glass needed for the appropriate frame. The glass could be found on racks located at their workstation or in the holding area for all other workstation glass racks located at the argon press. The solution for this project is to hire a material handler. Their task will include delivering and storing the glass for all areas throughout the facility. The second project is located at the classic Proline saw, and the objective for it is to increase the current productivity of 120 units to 160 units per 8-hour shift. This will be done through a time study, process flow map, work sampling, and a rapid entire body assessment.
As you can see here, this one operator has to load material into the saw as well as take completed parts out of the saw and place into the respective bin. The goal was to be able to compare the throughput of the machine with 1 versus 2 operators and understand the allocation of time spent while working on the classic Proline saw. The solution for this project is to run the saw full-time with 2 operators versus 1. As you can see here in a time study comparing 1 operator versus 2, 1 operator being the blue and 2 operators being the orange, the cycle time of the saw decreases significantly with 2 operators versus 1. It is also important to note that Windsor Windows should be able to use 1 saw and be able to meet production until the year 2025.
The objective for Project 3 was to reduce the safety risk at the wood casement workstation while increasing the operator's satisfaction. This was completed through a safety analysis, an operator discomfort survey, and by improving ergonomic workstation design.
The scope of this project is to evaluate and redesign the current workstation where operators lay sash into the frame. The sash ranges in all sizes due to every window being a custom part. This workstation must accommodate all of these sizes. Operators take the sash out of a cart and place it into the frame that is laying on the conveyor belt. Next, they reach around the workstation to grab any tools they need, such as a screwdriver, pliers, or clamps. Then they lift the part off the conveyor belt and rotate it 180 degrees to place onto a separate conveyor belt. The operators are rotating lifting parts that range from 20 to 200 pounds and then are walking into the separate conveyor belt to place these on the side jam.
This is a picture of the new SolidWorks design with the following changes. The width of the table decreased from 45 inches to 30 inches, and the length of the table decreased from 63 inches to 42 inches to accommodate smaller windows, while the table still has the ability to handle the larger ones with the extended arms. In addition to this, moving the blue bins to the inside of the table so they lay flush with the table on top. And tools may now be left on the top of the table to give the operators easy access to them while working. The first project has a 3-year net present value of $450,000, as well as Project 2. Project 3 does not have a financial impact due to it being based on operator satisfaction. These projects together total a 3-year net present value of $900,000. Thank you for watching, and we hope you enjoyed our project as much as we did.